Good afternoon, class. Today we're going to be continuing our discussion on waves. Today we're going to be learning about sound waves. To start you guys off, I want to do a review of the different wave types. In your Google document, you have a link to a YouTube video. Please open and view the video. The video's topic is
transmission of sound.
Please take some time to view. Let's go over the summary part together.
Summary. Every sound is produced by a vibration. Vibrations are produced by our vocal cords when we speak. There are two types of waves, transverse wave and longitudinal wave.
Which type of wave is a sound wave?
In a transverse wave,
If you said longitudinal wave, you would be correct. I'm going to skip through this part. Here's a review of the demonstration of how a longitudinal wave works.
direction of the wave. Sound waves are longitudinal waves. Sound travels quickest through a solid. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz.
Sound is measured in hertz. Hertz is a measure of the frequency of a sound wave. In our explorations today, we will be discovering how the frequency of a sound wave affects the sound. We will also be discovering how the amplitude of a wave affects the sound. Remember that amplitude is the height from trough to crest, and wavelength is the distance from crest to crest, or trough to trough. Once you have viewed the video, we're going to be doing a simulation. You can find the link for the simulation in your Google Doc. Let me offer you a demonstration. Click the left arrow. The bell moves to the left and creates a sound. Now click the right arrow. The bell moves to the right and creates another sound. Keep in mind that sound waves actually travel in all directions. This just shows the directionality of a longitudinal wave. To reset the simulation, click the green flag. Feel free to play around with this a bit. When you are done with the simulation, record your findings. What are some things you notice? Now we're going to be watching another video. We're going to watch this one together, so I can comment.
I'm Mr. Earl. Here with another.
Oh, wow!
Slowly, at the Children's Museum in Houston.
Hey, watch the string vibrate back and forth as I pluck that. Put your hands here. You can feel the sound coming out of the speaker.
Of course, sound is vibration. Right? Try this. Put your hand up to your throat and hum.
Feel free to try this. Put your hand against your throat. Now hum. Try speaking, or singing, or humming your favorite tune. Can you feel the vibrations?
What's your feeling? vibration created by your vocal cords. Sound is vibration. Let me show it to you differently. Before we begin, remember, science is fun, but it can also be dangerous. So always have a responsible adult helping you.
You may need an adult to help you with some of this. Please take out your packet that I sent home with you. In it, you should have all of the materials you need for this experiment. I'm going to let him run through the instructions. I will comment to show how we will do it differently.
So to visualize the sound vibrations, we're going to use a free frequency generator that I downloaded to my phone, a speaker that I hooked up to an audio jack, and a visualizer that we're about to build.
You will not need the speaker or the frequency generator. We are just going to be building the visualizer.
To make our visualizer, cut off the end of an 11 to 12 inch balloon so you have just the main part of the balloon remaining.
You may need an adult to help you with this. Go ahead and do this step now.
Now stretch the balloon over the top of the cup so it is on nice and tight.
Complete this step as well.
Next, cut a hole in the bottom of the cup that is just a little smaller than your speaker.
You may also need an adult to help with this step. Be careful.
As you can see, it doesn't have to be pretty. Tape or glue the speaker to the bottom of the cup.
We don't need to do this part.
Add a little salt on top and you're ready to go.
This part you do need to do.
The frequency generator is a program that plays only one note at a time, which makes it much easier to see patterns in the collection of sounds. As you can see, different notes cause different patterns to form in the salt because each note is a different vibration. And
This is similar to how a speaker works. Obviously, you can't do this part without the frequency generator. But try speaking into your cup. Careful not to spill the salt everywhere. You can see the vibrations that way too.
you don't really need a frequency generator, just talking to the cup makes the balloon vibrate. This has been another Oh Wow moment from the Children's Museum in Houston. We hope your mommy can come out to play.
Now we'll move on to another activity. For this activity, you need a computer that has a microphone. If you receive a message asking you to use the microphone, click Allow. You can also use a USB headset. As you can see, this registers the sounds that I'm making. Go ahead and try it. Try playing music. Get a group of people. You can also play with the dials on the side. You can make the waves bigger or smaller. This is a really good visual of how sound waves float through the air. Try playing around with the simulator a bit. Next, we'll be doing another scratch activity. This is a simulation that I have designed. This simulation contains 3 different slides. You can maneuver between the slides with the next button. This slide shows diagrams of different waves. You can see that some have a short amplitude and some have a tall amplitude. Click on the microphone to see how it affects the sound. These ones have different wavelengths. This one has a long wavelength. This one has a very short wavelength. This one is high frequency. This one is low frequency. Click on the microphone to see how it affects the sound. The next slide shows a variety of waves of different wavelengths. They all have the same amplitude. Click on the dot to see what it sounds like. Try experimenting. Play multiple sounds at once, or click one dot multiple times in rapid succession. What does it do? When you click a dot multiple times, how do you think that changes the wave? The final slide is an interactive xylophone. You can play it by clicking on the keys. Try playing a song. What do you notice about the length of the keys? How does it compare to the sound that they make? Try playing around with the xylophone for a little while. Once you have tried all 3 slides, record any observations that you might have made. We will discuss this in class tomorrow. After completing that simulation, I have another simulation that I want you guys to explore. Start off with a low amplitude by clicking the low box. Try adjusting the frequency. How are the yellow squares affected? The top shows a transverse wave. The bottom shows a longitudinal wave. Reset the frequency to low. Try adjusting the amplitude. Feel free to mix and match and play around. When you're done exploring this simulation, I have one final video for you guys to watch. This video gives a preview of tomorrow's lesson that we will be completing in class. Feel free to watch it if you want an overview of the experiment that we will do. Be sure to bring any observations that you noted to class with you tomorrow. We will be discussing today's video lesson. I hope you enjoyed all these simulations, and I hope you learned something about sound waves. See you guys tomorrow.